All right, we'll start it off with the definition of a rhombus. The definition of a rhombus is a quadrilateral with 4 congruent sides. So, to start off our proof, that's all we can use. But we want to go ahead and look and see what else seems to be true. So, what seems to be true about these guys here? Hopefully, you're recognizing that we would have 2 sets of parallel sides. And hopefully, you can, what are we saying? Oh, we're just talking about the sides, that's it. So in other words, it seems like it really is a parallelogram. So, in order to do that, I need to draw in some triangles. And you don't want to go hog wild. More triangles doesn't make it easier. It makes it more complicated. So you want to look and see if just drawing one set would be enough to prove congruency. Parallel lines, rather. So if I do that, and if I were somehow able to say that these 2 angles were equal, then I would get these 2 guys were parallel. And if I could do these guys, then I could get those guys were parallel. So I want to prove these. Now, of course, you could have done PR. It doesn't really matter. Either way is totally fine. So I want to prove that PQRS is a parallelogram. I always have to start with my given. And from your given, the only thing you are allowed to use is the definition from our rhombus. So I know that PQ equals QR equals SR equals PS. And that is the definition of rhombus. Again, there's only one definition, so you can just say definition. There are lots of theorems, so you have to be more specific when you're talking about that. All right, so I have, let's go ahead and mark it, all equaling each other there. Wow, congruent triangles should happen pretty quick for you. Hopefully, looking at here, you can see what else you can get easily. Oh, I forgot again. Why do I keep forgetting this? We need to draw QS, auxiliary lines. And then I can use that to say that QS equals QS. And that is reflexive. And hopefully you see it now. We've got 2 triangles that are definitely congruent to each other. So I can say triangle PQS is congruent to triangle R, and it doesn't matter. They're all the same. QS. And I'm also going to say is isosceles. At the same thing. This here gives me isosceles, and it's also congruent. So we've got that, and our little thingy here is SSS. So now I need to get some angles that are equal to each other. So I can get that these little dudes are equal. Actually, do I want to say that? PQS and R. I'm going to go ahead and do these the other way, just so that it's simpler, because then S and Q match up, so I don't have to be all crazy, the S and Q. So let's see, angle PQS and RSQ. And that would be congruent triangles, give me congruent parts. And I also have these guys here. So angle PSQ is equal to angle RQS. Again, same reason. Okay, and that's all we need, because then these guys are going to give us our parallel. So let's look at this carefully. These little dudes here was that. So that's what we're going to get. PS is parallel to QR. And alternate interior angles that are equal to each other give us that we have parallel lines here. Order makes a huge difference. That's why I've been emphasizing so much how it is that you write that. And then our other little situation here are these guys, and so we have that little spiel. That's this guy here, and then this guy here. So we have, what is that? Q is parallel to SR. Again, alternate interior angles that are congruent to each other give us our parallel lines. So what does that mean? We always have to go back. We're trying to prove that it's a parallelogram. Why does this prove that it's a parallelogram? Hopefully you're recognizing that we're still using the definition of parallelogram. That here, if I had a parallelogram, I would know this because of the definition. Or if I know this, I would have a parallelogram also because of the definition. So, if this is true, such an important question here. If this is true, what else do we know about the diagonals of a rhombus? Well, yesterday we proved that the diagonals of a parallelogram bisect each other, which means that this time I know that the diagonals bisect each other because I'm using the theorem. And actually, you know what, let's save this. If I were to draw in something like that, I would be able to say that PE is equal to ER and SE is equal to EQ. Theorem bisect each other. Okay, so that is what we've got. Again, once we know it's a parallelogram, we can use the one of the theorems that we already had there. So now what we want to do is do a different one. It says, what do the diagonals do to each other and to the interior angles of a rhombus? So if I'm talking about what they do to each other, I really need both of them. So I'm going to draw some auxiliary lines here. So we're going to draw SQ and PR and label E. And the reason we're allowed to do that is we're just connecting dots. So it is drawing auxiliary lines. So what we want to do is we know they bisect each other. What else seems to happen? If you look at this, it appears 90. So we're going to try to prove that. We're going to try to prove that the diagonals are perpendicular to each other. And if you look here and you look here, it appears that these two things are equal and these two things are equal. Now let's go back over here with a parallelogram. That was not true. These guys are not equal to each other. This is slightly bigger than that. So parallelogram, not true. Rhombus appears to be true. So we're going to say that the diagonals bisect the interior angles. Now, this is the toughest one yet in terms of choosing the triangles to prove congruent. If I prove these two triangles congruent, which are, and I can, I'm going to have a really tough time saying that these two angles are perpendicular to each other and that these two angles are the same. What I really want to do is prove two of them kind of right next door to each other, because then I can say that that's been bisected because it's been cut in half. This is a little bigger. And I can also somehow prove that these are 90 degrees. So that's my goal. So I'm going to go ahead and do that by starting off with our given. And what I can use with my given is I know the definition says that these two guys are equal to each other. What I have just proven is this, that the diagonals bisect each other, so I can get these guys equal to each other. So let's see, I know it's a rhombus, which means PQRS is a parallelogram, which means that PE is equal to ER because diagonals bisect each other. Okay, So I've got those, and then look, to prove these two triangles congruent, I'm like done. SE equals SE. And I'm going to say reflexive. That is enough. I'm going to have triangle PES is congruent to triangle RES, and SSS will be my reason. So I'm going to put numbers in here, 1 and 2, and also 3 and 4. So we're going to do bisect interior angles first. It's going to be the quickest and easiest one to do. So we'll go ahead and do and say angle 1 is equal to angle 2. Why is that true? Because our pair are congruent triangles. And that tells me that the diagonals bisect the interior angles. And that is the definition of bisect and interior. Okay? We also want perpendicular. We have done this before multiple times, in fact, but we'll do it again. If these two guys are equal, why? Because congruent triangles. And I know that they're supplementary. Together, we can say that they're equal to 90 degrees using substitution. And if they're 90 degrees, what that means is that PR is perpendicular to SQ. Definition of perpendicular. And oh, I needed to actually say the diagonals are perpendicular. So that is the definition of diagonals. Okay?